You're on a test flight aboard America's newest jetliner, the Boeing 737. This is one of 6 airplanes used to complete a 1,200-hour certification program. When the twin jet enters passenger service, this cabin will carry some 100 passengers. Until then, its cargo is engineers and their test equipment. Aboard the 6 test planes are 800 instruments to record on magnetic tape such data as engine performance, aircraft stability, and airflow.
The 737 twin-engine jetliner was to become Boeing's greatest success. Launched in 1967, the short-range transport entered service the following year and has remained in production ever since.
For the 2-man crew.
More than 6,000 737s have been manufactured today, and on average, 1,250 of them are in the air at any one
can be
time.
controlled from the steering column.
The 737 was based on the underlying design of the
short-range
727,
twin jet
a fact that
provides
saved a
cabin width
significant
equal to
amount
the
of
largest
development time
jetliner
and
flying
money.
today. By the way, those barrels are
Improvements
not for the
included
crew's
nacelles,
benefit.
the engine
They
covers,
contain 4.5
mounted
tons
directly
of
on the
water,
underside of the
pumped from
wings,
barrel to barrel.
which reduced the
It
weight
varies
of the
the plane's
wings and
balance
made it
point for
easier
test
for
purposes.
ground engineers to access the
Activities of
engines.
pilot, engineers, and
The
airplane
testing
are
process was
recorded on
intensive,
magnetic tape,
covering every
which reads
aspect
as
of the
many as
airplane's
43
construction
instruments at
and
once.
performance.
In this stall test, crew and engineers proved what 737 designers had expected. The twin jet is both stable and nimble. Many of those same designers brought the 727 and 707 into the airline world. In the 737, they have combined the best of all previous Boeing aircraft. The 737's high lift devices give it one of the lowest approach speeds of any jet transport, a great asset in landing at the smaller airports on its proposed 100 to 1,300-mile airline routes. As a business jet, the 737 can provide intercontinental range for global business operations. After test flights, engineering data is fed to computers, where information gathered during an hour's flight can be processed in less than 4 minutes. Between flights, the 737 has proved its easy maintainability. Departure reliability exceeds that of all other Boeing jetliner models during their testing programs. Wing-mounted engines can be inspected and serviced without extra equipment. Major systems are quickly accessible. In the main wheel wells and belly hatches, hydraulic and air conditioning units are inspected with ease. Just behind the nose wheel, the twin jet's replaceable electronic equipment locks into easy-to-reach racks. An auxiliary power unit on the airplane provides energy for the 737 systems and for self-starting of the airplane's engines. Fueling also requires minimum equipment.
But while it was the 737 that was to become the workhorse of the skies, Boeing's next offering, the 747 jumbo jet, got all the attention. This giant stretched more than 70 meters in length, roughly the size of a 23-story building, with a wingspan of just under 60 meters. In a two-class configuration, the 747 could carry an unprecedented 452 people across its 2 decks and hold 3 times as much baggage. It was powered by 4 JT9D Pratt & Whitney high bypass turbofan engines that delivered twice the power of conventional turbofans, making it the fastest subsonic aircraft ever built. Rolls-Royce and later General Electric options were also offered. The aeroplane was so big that Boeing built a new assembly plant near Seattle just to accommodate it during construction. But despite its size and complexity, Boeing committed to delivering the first 747 to Pan Am Airlines by the end of 1969, allowing only 28 months for design and construction, significantly less time than usual. As the giant airliner took shape in its Seattle hangar, the 747 project team members earned the nickname The Incredibles for the speed and effectiveness of their work. 50,000 people and 1,500 subcontractors were employed to work on the 747. A spiral staircase led from the lower to the upper deck, which was generally fitted out as a first-class lounge. The second level gave the aeroplane its distinctive hump, but the height caused a few problems during testing. To be certified by the American Federal Aviation Authority, the airplane company had to prove that its entire plane load of around 500 passengers could be evacuated within 90 seconds. It took a couple of attempts to achieve a successful evacuation, and volunteers were injured each time. The most difficult exit was for those on the upper deck, who had to don a harness and be lowered by reel. In later years, when the upper deck was converted to passenger seating, emergency slides were used. The 747 made its maiden flight on February the 9th, 1969, and the following year touched down. BOAC's first jumbo arrived at Heathrow in mid-1970, but sat on the tarmac for almost a year, until a pilot pay dispute was finally settled. As well as serving as a first-class lounge, the 747's upper deck could be converted to cargo space, and a freight loading door that swung upwards on a hinge was included for easy access. Boeing actually expected subsonic passenger airliners to be phased out within a few years in favor of supersonic airliners, so the 747 was designed for easy conversion to a cargo plane. It was soon evident that, as a cargo carrier, the giant airliner was indispensable. It wasn't long before 747 freighters were carrying half of the world's freighter cargo. The wide body was perfectly suited to carrying large aircraft components and pallets of machinery. Its 105-ton capacity made it beefy enough to manage the heaviest load. Boeing spent more than $1 billion developing the 747, but there were still significant teething problems, among them the safety and reliability of their engines. As the 747 underwent modifications and increased in weight and size, the engines became less effective, and the airliner was plagued by constant engine-related delays. Pratt & Whitney took more than a year to resolve the problems. In the meantime, up to 30 jumbos were left stranded on the tarmac. A bad look for a company that needed to sell a significant number of jets to keep its head above water. When a recession hit in the early 1970s, Boeing almost went broke.
Expect to be in service in early 1970.
A press conference held in 1970 saw Federal Aviation Administration officials grilled over their knowledge of recent 747 engine failures.
I don't know how to give a better non-technical answer, except that I have every confidence in the aircraft. When I said it's safe by definition, if it did not fully meet our certification requirements, the administrator would have no option but either to revoke or to suspend the airworthiness certificate of any particular aircraft or the type certificate of all of them.
This aircraft has a higher degree of overall reliability than 3 of the other common jets in service. And we have focused on the engine, but we have to focus upon the entire aircraft if you want to talk about reliability and safety. And as I told you, we do account for and expect the possibility of engine failures.
Although the engines got the all clear, there was more bad news for Boeing when news networks reported an incident of turbulence that saw 20 people injured on a Pan Am flight across the Atlantic. While turbulence was not unusual, one of the selling points of the 747 was its supposed resistance to bumpy conditions. Injuries ranged from cuts to broken bones. 11 people with minor injuries were treated at the Pan Am terminal. The others went to hospitals. One of those was a Pan Am stewardess who had just been starting a month's vacation.
It was just incredible, you know. People were, I'm really surprised that people weren't hurt, you know, or injured more seriously than they were. And I don't know, I've never been in turbulence like that, and I've flown for about 9 months. And we didn't have any hint at all that it would be that bad. I think the big plunge lasted, you know, maybe about 2 or 3 seconds, and then there was turbulence, heavy turbulence for about 20 seconds after that, and then it was all over.
What was it like in the plane? What was it like in the plane?
Well, people were exceedingly calm for what had happened. We thought the injuries were much greater than they were. A lot of people went into shock. A lot of people thought they had heart attacks. A lot of the stewardesses were hurt because they were up starting to serve. And there was a lot of crying, and children, of course, were very scared. But there were several men that took over and took very good care of everyone, and the stewardesses, did a fine job.
But it wasn't just 747s that grabbed the headlines in 1970. A Boeing 707 traveling from New York via Shannon, Ireland, was forced to make an emergency landing at Heathrow Airport after an explosion tore a hole in the cargo compartment.
Well, we had just reached our cruising altitude of 25,000 feet, and we had a loud bang. And
you heard that in the cockpit?
Yes. We monitored our engine instruments, which was our first concern, and they were all right. We checked our gear, and then the third pilot said that we had lost the cabin, which meant the cabin was climbing. We had lost pressurization.
What action did you take immediately?
So I immediately put on my oxygen mask and closed the throttles, pulled the speed brakes, put the gear down, and went into an emergency descent, which is a normal procedure for this type of thing.
Is this a steep dive you went into?
It's a rapid descent.
In retrospect, what effect did this all have on the passengers?
Well, when the cabin altitude reaches a certain altitude, the oxygen masks automatically fall out of the overhead panels, and they have oxygen on demand.
Did they use them?
So I presume they did use them. They were briefed before the aircraft took off from Shannon that
this was what to do.
This was what to do, yeah.
Just 6,000 miles. The plane's 3 giant engines.
The United States was also keen for its other large aeronautical manufacturing company to gain market share.
The airlines have already ordered a total of...
In 1970, McDonnell Douglas unveiled the DC10 and received governmental approval.
Among the first to tour the aircraft were Vice President Spiro Agnew and California Governor Ronald Reagan. The first DC-10 is scheduled to be delivered in 1971.
It was important for Boeing and McDonnell Douglas to make their mark early in the 1970s, as a new competitor was snapping at their heels. The European Airbus project was a joint venture between companies in France, West Germany, Britain, and the Netherlands. Their first design was the A300 Airbus, to be the world's first twin-engine wide-body aircraft. In December 1970, Henri Ziegler, president of France's Aérospatiale, and Franz Josef Strauss, president of German company Deutsche Airbus, formed a joint company, Airbus Industries, to build and market the airliner. The Dutch government and Britain's Hawker Siddeley Aviation were also associated with the company. Designed to carry between 260 and 300 passengers, the A300 was expected to cost $12 million US, about half as much as a jumbo jet. The alliance forged through the Airbus construction pioneered a new type of industrial collaboration in Europe. A central part of the fuselage was combined with a top half from Hamburg and mated to a lower half from Saint-Nazaire, with another component from Nantes. The wings were made at the British company Hawker Siddeley's Chester factory. Each piece of the jigsaw was then sent to Toulouse, where final assembly of the aircraft took place. Saint-Nazaire, on France's west coast, was a main U-boat base during the Second World War. Its new Battle of the Atlantic had the objective of beating the money-troubled US aircraft industry at its own game. But with so many nations contributing to design and construction, there was considerable worry that the project could become embroiled in politics. In 1968, the British government withdrew from the program after changes were made to the design, including the replacement of British Rolls-Royce RB207 engines with American General Electric CF650s. The government decision disappointed Hawker Siddeley, which was left, as one executive termed it, holding the baby. Prime Minister Harold Wilson was concerned that the A300 would go the way of the first Comet and the Concorde and become a drain on government coffers. He likened the international collaboration required by the project to a desert track littered with the whitening bones of abortive joint projects, mostly undertaken at high cost. Another reason for the British government's rejection of Airbus was its commitment to supporting the national airliner project of the British Aircraft Corporation, the BAC 311. A similar design to the A300, the 311 was mired in controversy over its design and cost, and whether the government should even be involved in the aerospace industry. The election of a Conservative government in March 1970 sealed its fate, and the following year, BAC abandoned development of the airliner. Despite the government's reservations, British company hawker Siddeley believed the A300 would be profitable and continued to work on the wings, financing the development costs in-house. The result? A design marvel that was a key factor in the A300B's later success as both a domestic and a long-haul carrier. More than 4 million man-hours and 4,000 hours of wing tunnel testing was spent developing and testing the wings. The wing skin panels were 15.5 meters long, milled in computer-guided machines and preformed in giant presses. As well as a change to the engine specifications, 1968 saw the size of the A300 scaled down. Sud Aviation Airbus program director Roger Béteille secretly commissioned his engineers to develop plans for the A250, a 250-passenger aircraft 25 tons lighter than the A300. When Béteille revealed his idea, the project partners agreed that a smaller, more efficient airplane would do better in the marketplace, and the A250 was renamed the A300B and put into production. With a diameter of 5.64 meters, the fuselage was big enough to accommodate 6 across seating in first class, 7 in business, and 8 seats abreast in economy. Béteille also raised the cabin floor slightly to accommodate 2 LD3 cargo containers side by side, an extremely clever innovation. Although Airbus had seen off the challenge of the 311, there was mounting concern that it would not have enough customers to become viable. Airbus industry was convinced that the American market would embrace the new airliner because of its similarity to the popular DC-10. Despite reports of a slowing aviation market and stagnation in the American economy, aviation traffic increased 11% between 1969 and 1970. Short to medium-range airliners captured 54% of seat miles, so Airbus was optimistic the A300B would find its niche. The London to Paris route was a key example. In 1958, there was just one route carrying 500 airline passengers a day between the two cities. By 1968, the number of routes had risen to 16 and was estimated to rise to 56 in the following decade. Airbus estimated it would sell 400 A300B airliners to service this and similar European routes.
The A300B is a wide-body aeroplane powered by 2 large fan jets and designed for short and medium-range routes. Design work and market studies started several years ago. And so the A300B was firmly launched.
With the wings coming from one place, the engines from another, moving the A300B components around the world was a major logistical challenge. Enter the Super Guppy, an enormous wide-bodied cargo plane manufactured by US company Aerospace Lines. The first Super Guppy was created from the fuselage of a C-97J turbo stratocruiser, the military version of the Boeing 377. With an inside diameter of 25 meters, the Super Guppy was the ideal vehicle to ferry outsized airplane parts. Airbus used 4 Super Guppies to transport A300B components from their various factories to Toulouse for final assembly. The joke went, every Airbus is delivered on the wings of a Boeing. The Super Guppy had tremendous lifting capacity, but only needed a relatively short runway. Its sharp turning capacity belied its ponderous size. The US Space Agency used Super Guppies to transport rocket sections between California, Alabama, and Cape Kennedy. Without a cargo aircraft this big, the agency would have had to ship components along the Panama Canal, a journey of several weeks. Super Guppies could cruise at 265 miles an hour, carrying a 40,000-pound payload. Unlike earlier transport giants, the Super Guppy's fuselage was custom-made and featured a bigger cargo compartment, a fully hinged fuselage for easy access, and a pressurized cabin.
Airbus Industries' own Super Guppy. Its destination, Toulouse, carrying large sub-assemblies, a rear fuselage or a center section, a forward fuselage or the wings. All the parts that go to make up the world's only wide-body twin jet, the A310B.
It was certainly a mammoth undertaking. When the components arrived in France, they were transported along country roads, presenting an amazing spectacle. Although the Airbus featured the first composite materials used on aircraft, making it much lighter than its competitors, its pieces were a major logistical challenge to move. French townsfolk gaped as the trucks made their way cautiously along the narrow roads. Finally, they arrived at the Toulouse Assembly Hall, where the center wing box section was pushed into position. The following morning, the rear fuselage section was moved alongside the assembly line, ready to be connected to its sister parts. Toulouse was the focal point for the Airbus program when the orders finally came in, delivering hundreds of A310B aircraft in the first few years of manufacture. And it remains the Airbus manufacturing hub today.
At Toulouse, a number of flight deck mock-ups have been built, including a flight simulator built alongside the Concorde simulator and sharing the same computer. Says Max Fischl, one of Airbus Industries' test pilots, and his crew, who have been closely involved in the design of the spacious flight deck. Airline pilots were also consulted.
Finally, it was time for the most anticipated moment of the A300B schedule, its official unveiling. It was the world's first glimpse of a completed A300B, and the aeroplane taxied around the tarmac without incident before being parked next to another European technological marvel in the form of the Concorde. On the 28th of October 1972, a month ahead of schedule, it finally took to the skies, spending an hour in the air over France on its maiden flight. At the controls were Aerospatiale veteran Max Fischl as captain and head of flight testing, Bernard Ziegler second in command. Although protocol usually dictated that the boss was captain on the maiden flight, Bernard, son of Aerospatiale CEO Henri Ziegler, said he wanted to reverse that to make it a team effort. I was not willing to have any longer a star in the system, he said. The decision was to the surprise of the Airbus management of that time, Bethey and my father. Airbus and Boeing went head-to-head in the aviation market of the 1970s, but it was the loss of two Boeing 747s in the world's worst aviation disaster at Tenerife that was to grab the headlines in 1977. No mechanical factors were to blame, rather a chain of circumstances and human error that led to the loss of 583 lives. Pan Am Flight 1736 and KLM Flight 4805 had been diverted to Tenerife Airport on the Canary Islands after a terrorist bomb exploded at their destination, Gran Canaria International Airport. Together with three other airliners, the 747s were parked on the airport taxiway while they waited for clearance to take off. At the same moment a thick fog rolled in, the KLM pilot misinterpreted an instruction from air traffic control and started to take off before the taxiway was clear. He hit the Pan Am aircraft, causing a fire that killed everyone on board the KLM flight and 335 of the 380 people on the other plane.
The mist hampered would-be rescuers throughout the night. When it lifted with the dawn, even those who'd been on the scene through the hours of darkness were shocked by the carnage. Both aircraft had been ripped into pieces. few and far between of the many thousands of these pieces were those recognizable as having only a few hours before been part of an aircraft. The runway was carpeted with the pieces of wreckage, mingled with the remnants of passengers' personal baggage. The pictures can show this horror. They can't convey the stench of the dead, of the smouldering still of the two aircraft, a stench which hung over the airport long after the last flames had died and the last bodies had been removed. Once this task had been completed, the workers seemed, not surprisingly, to hardly know what to do next. Most of the dead were still strapped in their seats as though ready for takeoff. One mother was still clutching her small daughter to her bosom. The witnesses could only talk of the horror of it all.
Well, my first thought was, wait, the fire engines would come out there. But then it got so bad where we were that, and we knew they weren't coming, that we had to get off. And I knew that I wasn't going to stay in there and burn up.
And how does it feel to be a survivor in what is the world's largest air crash?
It feels great to be alive. I'd be lying if I said anything else.
Both planes burst instantly into flames at the moment of impact. Thousands of jagged fragments were thrown out and scattered over a 200-yard stretch of the runway. They're all burned and twisted, and they've left the runway surface pockmarked with dents and holes where the tarmac's melted. This is Tenerife's only runway, and it's going to stay completely unserviceable for some time. The collision happened on the ground, and so the wreckage, although strewn over a long stretch of the runway, is concentrated on the tarmac itself, and that accounts for the degree of damage to the surface. Investigators have already begun piecing together what happened. This time, their task is not the usual one of finding out what mechanical failure there might have been, but of trying to establish why two jumbo jets were on the same runway at the same time, both preparing for takeoff. Survivors from the Pan Am Jumbo had an escape nothing short of miraculous. All climbed out of the front of the fuselage, out of the cockpit and the first-class compartment. One survivor said, "The top of the plane was sheared right off. There was just a big open place. I crawled through the debris, jumped down the side of the plane and ran." Another said there was no panic after the crash. The main thing most of the survivors were trying to do was to get as far away as possible from the plane. An American, Mr. James Nake, one of the tour organizers of the Pan Am plane, said his greatest fear was for his wife. He said she couldn't take the buckles off her seatbelt and she was impossible to move. "I tried to pull her up," he said, "and then there was an explosion. I was thrown out of the plane. I looked and saw the whole plane on fire. Another explosion and my wife was thrown out. She's now in hospital seriously injured." Meanwhile, the airport stays closed and the investigation into exactly what happened is likely to be a long one.
Despite high-profile accidents such as Tenerife, Boeing's market ascendancy was affirmed the following year, when British Airways infuriated British nationalists by announcing its plan to acquire more than 100 Boeing planes worth £1,000 million. Critics said the decision would sound the death knell for Britain's aeronautical industry.
I cannot believe that British Airways, which is a publicly owned corporation, can, by its ordering policy, jeopardize the future of a whole industry in Britain. An industry, of course, which has tremendous technological fallout for the rest of British industry. So I'm very hopeful. I'm sure that the interests of British people will predominate, particularly as British Aerospace are confident that they can provide a viable British alternative to the American machine.
BA did go ahead and order the American-made jets. But as with earlier BA Boeings, the aircraft were fitted with British-built Rolls-Royce engines. In 1979, Britain re-entered the Airbus consortium, with British Aerospace taking a 20% stake in the company. Chinese Premier Hua Guofeng visited the German city of Hamburg to inspect one of the Airbus factories. The Airbus consortium was keen to court the leader of the world's biggest country, which had shown signs of interest in the wide-body aircraft. The Premier was given the chance to open the throttle of an engine being tested, taking it to full power within 5 seconds. By this stage, Airbus was starting to manufacture its next model, the A310, which was a shortened version of the A300B. The A310 had a bigger range than its predecessor, making it a popular choice for transatlantic routes. It was specifically marketed to developing countries such as China and remained in production until the late 1990s. Several were later converted to multi-role tanker transport and used in air-to-air refueling.
The visit is very good news for Britain too, because while they may build the bodies here in Germany, we in Britain, of course, build what keeps the Airbus flying, the wings.
In the United States, there was much soul-searching going on following the crash of a DC-10 in Chicago that left 273 people dead. It was the fourth fatal accident involving a DC-10 in a short period of time, and concerns were raised about the safety of the aircraft. However, the investigation concluded that poor maintenance procedures by American Airlines and deficiencies in the FAA's surveillance of the airline led to the accident.
And found evidence in your records indicating that as far back as 1974, there were questions being raised about the pylon assembly.
The investigation also revealed damaged aft bulkheads in the wing-to-engine pylons.
To make sure
DC-10s across the
an
world were
exceptional
grounded for a
pattern
month
of
until the
failure in
problem
this
could be
area
fixed.
at all. That it was a fairly small number and it was contained and it did not pick up a pattern at all.
It occurred from the factory original installation. Nor has sought or thought that they might call it to your attention.
Mr. Chairman, I can only repeat that it would be helpful to us if you would let us have this paper.
We'll give it to you. It's your document. It'd be helpful to the public if you'd read what your people send you that affects air traffic safety.
DC-10 manufacturer McDonnell Douglas was later taken over by Boeing. In all, 386 commercial DC-10s were built in the 22 years it was in production. 60 KC-10 tanker cargo models were delivered to the American Air Force. As the number of flights around the world increased during the 1980s, so did the number of fatal accidents. In 1982, Air Florida Flight 90 collided with the 14th Street Bridge in Washington, D.C. and crashed into the Potomac River, killing 78 people. Like other planes preparing for takeoff at Washington's National Airport that day in January 1982, the Boeing 737 had been de-iced, a routine procedure involving the spraying of an alcohol-based liquid on a tailplane and wings. The fluid dissolves existing snow and ice and should prevent the buildup of any more. Other parts of the Boeing, like the leading edges of the wing, have built-in de-icing elements. However, a problem arose when the ground service's tow motor that was moving the 737 away from the gate was unable to get traction on the icy ground. The pilots attempted to back away using the reverse thrust of their two engines, but the engines simply ingested ice and snow. When the aeroplane finally reached the taxiway, it was forced to wait in line for 49 minutes until cleared for takeoff. Despite the long period of time, the pilots decided not to delay the flight further by reapplying de-icing liquid. On takeoff, they did not activate the 737's anti-icing systems. The cockpit voice recorder later revealed that the first officer had commented to the captain, "It's a losing battle trying to de-ice these things. It gives you a false feeling of security, that's all it does." The captain replied, "Well, it satisfies the feds."
Who knows that it was done right? If the pilot didn't actually check himself to see that the wings were clean, then maybe they weren't. Because, you know, these people are out in the sub-zero weather and they're out with this gun and the spray is coming all over them and they just can't wait to get the thing out of there and go back to the snack bar.
Ice and snow on the runway can have a serious effect on the acceleration of an aircraft. If it hits a bank of ice or snow or a lump of slush, it can slow the aircraft dramatically, and there is only a limited length of runway. If you don't achieve your speed at the right time, you may not have the distance to stop under those conditions.
But accidents aside, airline travel grew in popularity throughout the 1980s, helped by the rise in low-cost carriers that made the cost of air travel comparable to bus travel. US airline People Express came to London in 1983 to discuss plans to operate a service from England to America that would cost just £100 each way. It was the dawn of a new age in aviation, where passengers forewent established luxuries such as free food and drink in favour of cheap tickets. But with Britain's first no-frills airline, Laker Airways, forced into bankruptcy in 1982, what made People's Express think it could succeed?
Combination of factors. One, we have a very strong route system at the U.S. end of this route. At Newark International Airport,
when you say a route system, you're talking about connections?
Yeah, a connecting system at Newark International Airport with over 200 flights a day into and out of that airport. It provides a strong feeder traffic for this route, unlike Laker, which did not have that system on either end of the New York-London route. Secondly, and very importantly, is our cost structure. We have not purchased new aircraft, we purchased used aircraft. We have a very efficient system, so in turn we produce a very low cost per seat mile. When you've got that low cost, you can then take the risk of having lower fares and recognizing that you'll generate the traffic and still make a profit.
The aviation industry of the early 80s was a difficult market to survive in. A world recession, combined with a massive hike in fuel prices, contributed to a situation where many airlines ran into deep financial trouble. Still government-owned and operated, British Airways was being prepped for privatization. When £500 million was required to pay redundancies to 23,000 people to trim down the airline and make it more appealing to investors, the cost was borne by taxpayers. But other British airlines were on their own if they got into financial trouble, and the most prominent casualty of the 80s recession was Laker Airways. Founded in 1966 by entrepreneur Sir Freddie Laker, the airline's SkyTrain flew between London and New York at a cost of just £38 a ticket. The airline eventually folded due to crushing debt. But some analysts still saw a positive future for the low-cost model.
In the United States at the moment, all kinds of business at the moment are beginning to come back into prosperity, and this includes the airlines. The airlines are getting more people who travel with them. They are able to charge more money for their fares because there are more people who want to travel with them. In the rest of the world, really, the rest of the world's not ready for this quite yet, but next year, I think it probably will be.
So you don't see many new airlines starting up like People's Express?
Well, People Express, as you know, is an American one, and they have come into existence because of the deregulation system in the United States. But they're not the only airline which has come into existence. About 50 new airlines come into existence every year in the United States. Now, maybe only about 10 of them will actually survive or keep successfully going, but there are a number of new airlines emerging in the United States every year. Airbus has decided that the next aeroplane it wants to go for is this thing called the A320, because they've decided, for example, that the largest area where airlines are going to need new airplanes are the 130 to 150 seaters. That means things like the Boeing 737 and the Boeing 727, and then McDonnell Douglas's DC-9. This thing which Airbus wants to produce, the A320, is going to fill that part of the market. And we're talking about a part of the market which over the next 15 years is going to require 3,000 new aeroplanes of that type. And Airbus reckons that they'll get about half of that market, and Boeing and possibly McDonnell Douglas will get the other half.
The battle was on between Airbus and Boeing throughout the 1980s. The Boeing 747 remained a perpetual favorite for long-distance travel, its 4 engines making it essential on long hauls from Australia to Asia and Europe. Thai Airways International flew the Jumbo on its Australia to Europe route. The airline began life as a joint venture with Scandinavian Airline System in 1960, before the Thai government bought out SAS in 1977. But in the aviation market of the time, there was more demand for short to medium-range airliners. Airbus decided to build on the success of the earlier Boeing 727 by developing the A320, a narrow-body aircraft with greater fuel efficiency, improved technology, and cheaper operating costs than the 727. Private carrier British Caledonian quickly put in an order for 7 A320s. However, its rival British Airways decided to lease more Boeing while it evaluated the new aeroplane's performance.
Aren't Caledonian taking a risk?
Not a risk at all. I believe Airbus will build this aircraft. If they're going to build a new aircraft at all, they'll build the A320. There's a gap in the market for it. They're dedicated to it. They've got a fine product there in the A320, and I haven't got any hesitation at all.
Because Airbus was 20% British-owned, manufacturing the A320 was expected to generate more than 8,000 British jobs. But there was disharmony brewing in British skies. British businessman John King had been brought in to make BA into an attractive market proposition in preparation for privatization, a job he carried out brilliantly. But a Civil Aviation Authority report concerned British Airways, as it recommended reducing the number of routes BA could fly due to its market dominance.
I described it as a smash and grab raid. I suggest that his boarding party should have arrived when we were lying on our backs rather than now that we're standing on our feet. So I'm not interested.
The Civil Aviation Authority concluded that a privatized British Airways would be too big and recommended some routes, both continental and domestic, should be transferred to the other companies, notably British Caledonian. Independents Dan Air and Air UK stood to gain too. The CAA's proposal suggested a revenue loss to BA of £295 million and reduction in operating costs of £80 million. But British Airways executives were only prepared to accept changes which would cut £25 million off revenue and £15 million off operating profits.
We said we would produce an airline of about 35,000 staff, worthwhile in every way and forward-thinking and something that the people that work for it can rely on and look to. And we've had their faith and their trust, and I'm not about to break it up.
But one expert who used to work for British Airways said losing routes needn't mean losing jobs.
There is a reasonable tradition and precedent in air transport for staff being moved with routes. This has happened on a number of occasions before, and there's no reason why, for example, the Gatwick or the Birmingham services and their staff, and possibly even their aircraft, couldn't have been sold off to the independents.
Margaret Thatcher had earmarked BA for privatisation from the beginning of her term as Prime Minister. But sorting out a suitable route distribution became a major hurdle on the road to a private sale.
The exercise was set up because of the whole industry expressing worry about the structure of that industry after the privatisation of British Airways. That is the problem, and how that is being solved will really set the scene for the next half-decade of civil aviation. Now, to come forward with a rather crude piece of route swapping to try and solve that problem simply seems to me to be grotesque.
British Caledonian threatened to transfer its operation to Heathrow and jeopardise Gatwick's future if British Airways did not give up routes and revenues.
As a private airline, the size that they would be, I'm sure they would be predatory. They would have no inhibitions at all about what the government policy was towards airlines, and if they could squeeze us, they would squeeze us. That's why we have said that if the government privatizes them in the present form and doesn't adopt the Civil Aviation Authority's recommendations, then we would wish to move straight into Heathrow, lock, stock and barrel, and operate from Heathrow. It's the biggest international airport in the world. It's the best international airport in the world. We would earn about another £30 million of profit if we operated from Heathrow rather than Gatwick. We are serious.
David Learmont of Flight International said the Prime Minister had a real dilemma.
She's got two of her much-loved philosophies clashing head-on. Privatisation is one. She wants to privatise British Airways. The other is competition. She wanted to promote that, which was the whole idea of the Civil Aviation Authority study. Unfortunately, we've got an example, I think, of political expediency coming up here. And an example that the privatization philosophy is the one which Margaret Thatcher loves even more than the competition. The reason for this is that if she were to go ahead with the CAA's plan, people at British Airways might lose their jobs. Even though they might pick them up with the other airlines, they would lose their jobs. That would mean a strike at British Airways, which would mean Margaret Thatcher cannot sell British Airways for a reasonable price, or may not even be able to sell it at all. And that is what she fears. Therefore, she has to go British Airways' way.
Eventually, a compromise was reached, and a new look British Airways was unveiled in preparation for a public float. Its fleet of 150 aircraft were given new livery, and the multi-million-pound transformation received a laser-like quadraphonic send-off. But the livery to take the airline through privatization and into the 90s was more subdued than the brash style it replaced. It was back to the old British Airways logo, shortened to just British in the previous major revamp. It was part of the plan to make British Airways as appealing as possible to investors. Cleaning planes, well-dressed cabin crew, and modernized VIP lounges were designed to position the airline as a forward-thinking business that would thrive in the deregulated skies of the 1990s.
We hope to get the price right. We want the shareholders, we want a broadest possible base spread of shareholders, both institutional and others, and we want them to be pleased with that investment. And I'm sure they will be.
Thanks to Lord King's restructuring efforts, when BA stock was floated in 1987, demand far exceeded supply. The company had gone from being bloated and inefficient to a streamlined, profitable enterprise in just 6 years. Although airline stocks were flying high, a tragic accident at Manchester Airport in 1985 caused much soul-searching within the British aviation industry. On August the 22nd, British Air Tours Flight 28M caught fire on a taxiway. 56 of the 136 people on board were killed. The first sign of trouble was the loud thump under the 737 heard by the captain. Thinking a tire had burst, he abandoned takeoff and activated the thrust reversers to slow the aircraft down and gently maneuver it to a taxiway. Although this was standard procedure, unfortunately it gave the fire a chance to spread. Procedures were later changed to ensure pilots gauged wind direction before they turned the aircraft. The investigation revealed the cause of the fire was an uncontained engine failure in the number 1 engine, which punctured a wing fuel tank access panel. Fuel leaking from the wing ignited and burnt as a large plume of fire trailing directly behind the engine. The engine failure was caused by a crack in a combustor can on the port engine as a result of thermal fatigue. Cracks had previously been located and repaired in the engine, but the repairs were unsatisfactory. The Manchester accident was used as the basis for a series of studies on survivability and evacuation. The swift spread of fire into the fuselage, a door malfunction, and restricted access to the exits because of the galley layout contributed to the deaths. Only 6 people died of burns, with the remaining 48 succumbing to toxic gas and smoke generated by the burning fuselage and upholstery. There was much discussion in years to come over whether the use of smoke hoods in the cabin could have saved more lives. Safety regulators were undecided, saying they needed more evidence that smoke hoods would not cause more problems than they would solve. Smoke hood manufacturers said there was no doubt their product would enhance safety.
I believe very strongly now that as 2 years have already gone by since the disaster at Manchester, we have learnt an enormous amount, and we are prepared, willing and able to make products available to the fare-paying passengers which would indeed protect their lives. What is on offer at the moment is probably not perfect for everybody at all times, but it's certainly better than nothing.
However, authorities later decided against making smoke hoods a mandatory requirement, believing that they would ultimately hamper evacuations. The 1980s were a time of financial instability, new business models, and rapidly developing technology. Those airlines that weathered the storm were well placed to take advantage of the rise in passenger numbers that coincided with much lower prices. Passengers were less concerned with airline perks and more focused on the bottom line. Thus, the aeroplanes of the future would be designed with one main objective: the lowest cost per passenger that was possible.